Team Gambling is proud to present PokerSpace, a database system meant to streamline and simulate the data that comes from hosting or playing poker. Whether you run the casino and want to know the ins and outs of your service, or a player looking to win big, PokerSpace does it all. From managing customer accounts and transactions, to recording games played, quantities lost, and profits won. You've never learned more from gambling. Using our patented MySQL technology, PokerSpace provides insight into the best sector of the American economy to both business owners and consumers. PokerSpace. Gambling's never been cooler. Is that good?
So here is the schema for our project. We have 4 different tables, one called the player table, the house table, the table, and the current game table. The house table has a house ID, which is the primary key, a money storage, a money owed, and the number of tables. Then for the player table, we have the player ID, which is the primary key, then games played, quantity lost, account balance, small blind, big blind, and the table number, which is a foreign key. Then we have the table, which has the table number as a primary key, current round ante, winning hand info, current round winnings, and total pot value. Then lastly, we have the current game table, which has the game ID as the primary key, the table ID for the foreign key, number of players, and added pot.
The casino database is centered around 4 key tables: player, poker table, current game, and house. It supports full CRUD operations and makes strategic use of joins, aggregates, and constraints to maintain game integrity and simulate a real casino experience. To support responsible gambling, we introduced a user-defined function called getAnteStatus. It compares a player's balance with the table's ante and returns either safe to call or risky bet if the ante exceeds 50% of the player's balance. This adds an important layer of financial advisory to protect the player, one of our core goals. In terms of automation, we implemented both a trigger and a stored procedure. The trigger, update player balance, fires after a new game is inserted into the current game table. It calculates how the added pots should be evenly split among participants and automatically updates players' balance, maintaining real-time financial accuracy without manual intervention. Our stored procedure, getPlayerSummary, takes a player ID as input and returns a snapshot of that player's key data: games played, total losses, account balance, and current table information. It simplifies access to relevant insights through a single, word-structured query. To conclude, we included a set of highlight queries, each demonstrated useful business logic. Query 5 joins player and poker table to display each player's ID and their table's pot value. Query 8 uses aggregation to identify tables where total loss exceeds $50, highlighting high profit zones for the house. Lastly, Query 10 flags players with a negative balance, helping administrators monitor risk and enforce account limits.
When building our database, we wanted to go beyond just designing tables, so we got together and played some poker games ourselves to further understand the rules of the game and the business logic behind things such as payouts and player stats. With access to player and house data such as balances, pot sizes, and winning hand information, we were able to have a central place to run queries and get the information we needed quickly. This made the system feel intuitive and responsive during testing, allowing us to easily track player performance and simulate real casino scenarios. Overall, the experience reinforced the importance of designing for both functionality and usability, ensuring the database could support meaningful insights and future improvements.